So we have University of Hawaii coming out with the news that they believe that planets shrink. I'll go ahead and read a little bit of this out to you. I'm sure you guys have noticed the nice painting in the background here. Celeste did that for me. Good job, Celeste. We took a beach scene and we went over it and made it into an outer space scene with some highly evolved stars on it. So it's really cool. She says, delete, delete, delete. I don't think so. From centuries of studying the planets within our solar system, astronomers have wondered how planets form and evolve to become the ones we observe today. There's no more wondering. A planet's formation is its evolution. It evolves as it forms from its hotter state, which means it's an old star. A team of astronomers led by University of Hawaii at Manoa Institute for Astronomy graduate student Travis Berger found that an intriguing class of Neptune-sized planets shrink over billions of years. The study was published in the Astronomical Journal. One of the most surprising findings of the past decade was the discovery of a new branch in the planetary family tree, separating slightly larger than Earth, super-Earths, from those somewhat smaller than Neptune, sub-Neptunes. However, it is unclear how these different-sized planets formed, as observations are only a single snapshot out of a billions of years long lifetime for each individual planetary system. Of course, when you assume a lot of things to be true, then you ask questions based on those assumptions, you're going to be confused. And that's what they're doing here. They're assuming quite a few things. One of the things that stands out to me is they're assuming that a system is billions of years old. No, systems change. They mix, they mingle, they lose objects, they gain objects. They're very turbulent things. Maybe tens of millions of years old. Each system is only a couple tens of millions of years old. Systems aren't billions of years old. The individual objects themselves, the evolving stars, are the objects that are billions of years old. But because they're billions of years old doesn't mean that their orbit and their host star have been that way for billions of years. So there's a big assumption there that they have to work on. Astronomers cannot watch planets evolve in real time. Well, that's obvious. So they analyze populations of planets to infer how they form and evolve. Well, their formation is their evolution. They don't form and then evolve. It doesn't work like that. Using observations from the NASA Kepler and the ESA Gaia missions, Berger and his team have uncovered another piece of the planet formation and evolution puzzle. Again, they do the same. As planets are bombarded with intense light from their host stars, they gradually lose their atmospheres over billions of years. No shit. The planets that they call Jupiter-sized planets lose their atmospheres and evolve into Earth-like planets. And Earth-like planets become Mars-like planets. Uranus planets become Earth-like planets. Neptunes and Uranuses become like Earth. Earth become like Mars. Mars become like Mercury. It's a long chain of evolution. Adam told me, he was like, well, it should be obvious to these people if they found out that, lizards can evolve into snakes. Well, that's all. What life does. It evolves. Everything is interconnected. And for them to find just that little piece right there and go, oh, this is the big picture, it shows that they're still pigeonholing the whole thing. They have to extend it out all the way to the very beginning. Earth was the size of the sun and was as radiant as the sun and was as massive as the sun. But it's good to see that they're going in the right direction here, and I just wanted to share that with you guys. It's pretty incredible. We live in an extremely evolved star that's billions of years old. And the rate at which these objects lose their atmosphere is essentially the rate at which they evolve. So hopefully Travis Berger can see stellar metamorphosis, maybe